So let's change perspectives one last time, and let's talk about spherical coordinates. Okay, so like I said in the beginning of the video, remember that if we have a point x, y, z, okay, we can think about this point as living on the rectangular box, right? Or a rectangular box, I should say. But the coordinates really mean, okay, we go x units down the x-axis, y down the y, and z down the z, okay? So that's our Cartesian coordinates. Now, like the name says, cylindrical coordinates, instead of thinking about that point as living on a rectangular box, we're going to think about it as living on a sphere. Okay, and a sphere of radius, as you can see on the right here, a sphere of radius rho. Okay, that funny Greek symbol there. Okay, so that's the spherical. Visually, that's what we're doing with the spherical coordinate system. We're taking our points and we're viewing them as living on a sphere now. Okay, so not on a rectangular box like Cartesian and not on a cylinder like cylindrical coordinates, but now a sphere. Okay. So let me go ahead and discuss really quick what are our coordinates. So rho is the radius of that sphere. Okay, so notice it's the distance from the point to the origin. Okay, or if you think about it as on the sphere, that's just the radius of the sphere. Theta is the same thing it means in polar coordinates, so that's sort of useful. So theta is the angle the point would make coming off of the positive x-axis. Okay, and usually I'll say theta. Think about it as going from 0 to 2 pi, okay, or some sub-interval of that. Now phi here, which is this last Greek symbol, okay, this is the angle that that point makes off of the positive z-axis. Okay, so if you start at the positive z-axis and you bend over this way, okay, that angle that you make there, that's what we call phi. Okay. So these three coordinates are what we call the spherical coordinates of the point. So rho is the radius, theta is the same thing it was in polar coordinates, how far are you off of the x-axis, and then phi is how far you're off on the z-axis. By the way, so I told you to think about theta as being some subset or somewhere in between 0 and 2 pi. You can think of phi as just being, usually we can get away with between 0 and pi. All right. Now, again, in class, what we're going to be doing on Thursday is coming up with these relationships here. And they're slightly more complicated, but it does come back down to geometry. And again, I don't want to spoil it, but here's our conversions. So if you're going from Cartesian coordinates to spherical coordinates, okay, rho is equal to square root of x squared plus y squared plus z squared. Again, remember this is spherical coordinates. So that's why we're getting that kind of relationship there. Tangent of theta, like it was in polar coordinates, is still y over x. And then cosine of phi is equal to z over rho. Okay. Now, if you're going from spherical to Cartesian, okay, then x is equal to rho sine of phi cosine of theta. Y is equal to rho sine of phi sine of theta. And z is equal to rho cosine of phi. Okay. Now, again, these might seem like they're coming out of the woodwork, but again, notice in this picture here that your book gave you, look at all these triangles here. All these formulas are coming from geometry and triangle geometry, okay, and using all of your Pythagorean theorems and stuff in different ways. Okay. So let's say we wanted to integrate in spherical coordinates. Okay, so again, we would use our conversion formulas, but just like we had in polar and cylindrical, we do have to multiply by something else. Now, in spherical coordinates case, we have to multiply by rho squared sine of phi. Okay, and again, the reason for that is when we break up our solid in spherical coordinates, our rectangular boxes are transformed into these spherical boxes. And again, that's just for lack of a better word, spherical boxes. And so the volume of the spherical box is going to be altered by this factor here. Okay, so that's why we have to incorporate that as well. So let's go ahead and see an example.